we're starting a tour of the SourceCred codebase, kind of with a bunch of metagame hackers in ETHDenver. We're going to do an overview of like the plugin system and just kind of what's needed to add new stuff like this Discord plugin and Quest plugin we've been talking about. I am recording this because I figure then we can just show other people this recording, and someone who wants to learn about the plugin system has got a little bit of a head start. So I'm going to start actually with the contributing guide. In case anyone wants to contribute to SourceCred, we have a guide. It's called contributing.md. GitHub is very slow. We might want to just do this on them. Contributing.md. And this has a lot of information on how the SourceCred codebase works. Some things that are interesting to note: we use atomic commits, so we just make pieces of work really small and really easy to review. And we've got tons of testing. We've got flow checking for types. We've got unit testing. We've got shardiness testing for integration. We've got prettier to use a consistent format. We've got linting. We've got like Docker testing. We really like testing. So if you do want to make changes to SourceCred, or if you want to work on a plugin, please take a look at this guide to start. Now, secondarily, let's talk about the graph. So SourceCred is all about graphs. And the graph lives in the core/graph.js module. Graphs have nodes and edges. And you can look at both nodes and edges here. We have a type node. Nodes have addresses. The way we handle addressing is basically every node and edge has an address, which is a sequence of strings. So an example of a node address for something in the GitHub plugin might be like GitHub/issue/SourceCred/SourceCred/514. So it's like kind of like URLs, but it's not, hasn't got a URL identifier. At an implementation level, we translate these addresses out of arrays of strings and just into opaque strings with null byte separators. And the reason for that is so that you can use addresses as keys and maps. It's very convenient. But for now, let's just know that we have node addresses, we have descriptions, and we have timestamps, which is how we use for the timeline cred analysis. You'll note that nodes don't have arbitrary payload data. It's not like I'm going to say the node, like, I'm not going to include metadata on what kind of quest it was. I'm not going to include metadata on even what kind of reaction it is might get included in the address. That's conceivable. But generally speaking, the nodes are super lightweight objects. And if you want to store additional data, if you want to know like how many lines of code a pull request was, that would be in a different database, not in the graph. We also have edges. Edges have got an address. It's pretty much the same as node addresses, except it's a distinct type. So if you tried to like give an edge address when a node address is expected, you would get a flow error, which is nice. Edges have sources and destinations, which are identified by address. And edges also have timestamps, so we can do more timeline cred analysis. And then the graph, you kind of like, you've got a lot of different helpful methods on graph. You can add nodes, you can check for the presence of nodes, you can retrieve a node by address, you can iterate over all of the nodes, and you could put in a prefix. So if I, for example, want to find all of the GitHub issue nodes, then I would put in an address prefix of like GitHub/issue, and then I would only get the nodes in the graph that were GitHub issues. So that's often quite useful. We've got similar methods for edges. You can add an edge, you can check for edges. There's a concept of dangling edges. So you are actually allowed to construct an edge whose source and destination may not be in the graph. This is important because it allows plugins to create edges to each other. So if my discourse plugin is making a graph, it doesn't know about GitHub issue nodes. It can't set them up. It doesn't know the timestamp. It doesn't know the details. But it can create an edge to a GitHub issue based on its address. And so that's basically how we're able to like weave things together across plugins. And then again, you've got all these edges options. You can retrieve all the edges, but now in addition to filtering by the address prefix on the edge, so I could get all the edges that are of like GitHub reference type edges, you can further filter by what kinds of edges it's connecting. So I could get all the GitHub edges that start from a user, or all the GitHub edges that end at an issue, or I could even really get super specific and say all the like reference edges between issues and users, for example. We then have a helpful method called neighbors. And I'll mention as a side, as you can see, this all has nice doc strings, so you can just like read the docs on the graph module. Neighbors lets you basically say, I'm interested in a specific node. I want to find all of the nodes that are connected to this node, along with information about the edges. And soon we're going to have the same API allow you to also get cred flow information. So you'll be able to say, for this node, I want to know its cred. I want to know how much credit got from each of its neighbors, basically. And that's going to be really useful for building analyses, like how much cred did a user get from completing these quests. One final thing I'll mention is that oftentimes in our data structures, we're putting these to JSON and from JSON methods because we're using maps, and maps have horrible serialization semantics because JavaScript is a messy language. And we have got this compatibility layer. So basically all of the data types that we serialize get version information written with them. So that if you try to load an old version, it'll give you a clean error message. If you need to, you can provide upgrade handlers to port old versions into the new one. So that's the graph module. From here, I'm going to go into seeing how it works in some example plugins. But I'll pause and just see if anyone wants to ask questions about this stuff so far.
So I was just thinking about, so you had an idea of the node, and you have like the address and the description, and you said you didn't want metadata on there.
Mm-hmm.
So I was thinking, in terms of handling that process of what sort of is this was defined task or any of this other task, could we encode information in the address that we then map out in our system that basically if this address has this string in it, it represents a design task, and that we just have another layer on top of the SourceCred graph that adds labels to certain things that it might not be native to SourceCred.
Right. So I'll repeat the question since someone recording probably won't hear you. The question is, given that we don't have metadata on the nodes, but we actually do want metadata to affect credit analysis, an example of metadata being whether something was like a design task or an implementation task, basically how can we build an interface between the layer that has metadata and the SourceCred graph? Do you think that's a fair summary of your question? Yeah, so you absolutely can encode information in the address prefixes. So for example, let's say that you decided that metagame has got 3 domains of work. There's the path of the fighting, of stealth, and of magic, right? You could have every quest have in its address prefix. It could be it could be quest plugin / magic / quest information, or quest plugin / stealth / quest information. And then you'd be able to have heuristics that operate directly on that. And mint different kinds of cred, or in the future we may have colored cred where design cred is flowing separately from implementation cred. That's something we have on the research idea. The other thing I'll say is that you can just use the graph addresses as identifiers into an external database. So if you wanted to have custom stuff for every individual node, you would just have your database, and then SourceCred wouldn't know about the database, but your plugin would know about the database. And so your plugin, as it's constructing the graph, could look up properties in its database and then use that to set weights. And that actually makes me realize the next thing we should talk about is probably weights. But
yeah, and this is more flexible because when you use the address form, you only get to pick one set of prefixes, right? So if you wanted to see whether it's design or implementation credit, and also whether it's from a founder or not, it's harder to go through them. Yeah. Or if you just key it into a database. Yeah.
Right.
So all addresses are unique.
Yeah.
Globally.
Yeah. Or I would say all addresses are unique within a cred graph. I can't say globally because SourceCred isn't centralized, so nothing stops you from coming up. But a good plugin will be choosing globally unique addresses, I think. It will be tempting to do so. And if you try to merge graphs that have incoherent information, it will throw an error. So for example, if the GitHub plugin claimed that there's an issue that has a timestamp 3, and the Discourse plugin decides to claim that there's a GitHub issue with a timestamp 4, then an error will be thrown when they try to merge. So I'll talk about weights. There are 2 kinds of weights. There are node weights and edge weights. In both cases, we apply weights at an address level, and we again have prefix matching semantics. So I could say I want to wait on the whole GitHub plugin. I could say I want to wait on all GitHub issues, or I could say I want to wait on a particular GitHub issue. If a certain node or edge has multiple weights that could apply, then we take the product of all those weights. So if your issue has a weight of 2 and we decide to give all GitHub issues a weight of 5, then it will actually get a final weight of 10 from 2 times 5. What's really nice about this is it means that you can change these levels independently and still the system be consistent. So I could go and say, oh, actually, we're giving too much cred to GitHub. We're going to reduce the whole GitHub plugin by a factor of 2. And it will still respect all the individual weights that were set. Node weights right now, the thing that they're used for is minting cred. So most nodes in the graph will have a weight of 0 because we don't want them to mint any cred. We just want those nodes to flow cred as usual per the PageRank semantics. But for example, a quest, you probably want that to mint cred when a quest is completed. Right now we have likes and reactions minting cred, and I think that's likely to be the case indefinitely. So when you see node weight, you can think how much cred to mint. Edge weights are a little bit more complicated. Our edges are directed in the sense that an edge has a source and a destination. In fact, I'll just pull up this on the side. Yeah, so as you can see, edges have an address and a source and a destination. But the edge weights have both a forwards weight and a backwards weight. And that basically means every edge is capable of flowing cred in both directions. If you give an edge a forwards and backwards weight of 1, then it will flow cred evenly in both directions in kind of like a standard, like 1 is the standard weight. If you wanted an edge that only flows cred forwards, you would give it a forwards weight of 1 and a backwards weight of 0. If you want this edge to be really important, to really flow a lot of cred, then you could give it a higher weight. So for example, we might want GitHub issues to flow more cred to their authors than to their references. And if so, we would give the references edge a higher forward weight, whereas the is authored by edge would have a lower weight. The way that we decide, it's a little bit arbitrary which direction of an edge will be the source and which direction will be the dest. And so we basically just tiebreak based on how we represent the edges in English. So let me give an example. We're going to go into the GitHub declaration. So now we're learning a little bit about plugins. Every plugin has a declaration file where it tells you what types of data exist in the plugin. The reason for this is both so that you can set weights at a type level, and also so that the UI can tell you, you wrote 7 pull requests, as opposed to you wrote 7 nodes with a really complicated address that I don't know anything about. So a node type, you give it like a name, a plural name, you give it an address prefix, and a default weight and a description. Edge types, you give a forwards name and a backwards name. So an author's edge is called forwards in one direction and is authored by in the other direction. And the way that we decide which one is the source and which one is the dest is that whatever we're calling it, we basically make the verb go from the source to the destination. So if there's an author's edge, it goes from the author to the content that's authored. But it might be the case that the backwards weight is actually going to be higher than the forwards weight, and that's fine. So the main thing that plugins do is they create graphs. So if we were to look at, say, the discourse graph creator, I feel like it's a little bit cleaner than the GitHub one. So the way the discourse plugin works is we basically construct nodes for all the different entities that come from discourse. So we've got this user node function that takes the username and the server URL and returns a node for that user. As always, nodes have an address, a description, and a timestamp. For users, it doesn't really make sense for them to have a timestamp because it's not like, in a sense, we don't think of users as like coming into existence at particular times. We think of them as existing forever. We might actually change that, but it's a little more relevant here to think about, okay, we need an address for the user, and we want that address to be unique. And so this is why we take the server URL. If we made your address just from your username, then what if we someday are combining 2 discourse servers in the same cred instance? Somebody might have the same username might correspond to different identities on these different servers. So we put the address in we put the server URL in the address, and that comes from this user address function. So this address. And so a user address is just we take a node address and we construct it out of the shared prefix for the user nodes. So I'm going to stack. Okay, so we've got a user node type. Okay, we've never really like organized the plugins to make it easy to explain. So you're getting it all kind of raw here. So the way we got the discourse addresses is we first chose a shared node prefix for everything the discourse plugin creates. And we're making this SourceCred, discourse. The reason for that is we're actually scoping all the plugins as the organization making the plugin and then the plugin name itself. So it could also have been like metagame/quest. And this way, if metagame decides that they want to make their own better discourse plugin, it won't be like creating all these naming conflicts with our discourse plugin. So we're going to start, every node in this discourse plugin is going to have the node prefix SourceCred/discourse. Then on the type level, we're going to add one more piece. So all of the topic nodes are going to have the prefix of SourceCred/discourse/topic. And then when we want to make a topic address for a particular address, we make it the shared prefix, which is SourceCred/discourse/topic. Then we add the server URL, and then we add that topic ID. And so that's the general pattern for constructing unique addresses. Then we use that address and we construct a node. And then we're going to have a create graph method at the end that is basically going to go ahead and do things like, add every user node, add every topic node, and then start adding edges. So for every topic, we're going to add an edge that connects the topic to its author. For every post, we're going to add a post. And then the add post method is going to do stuff like, for every post, it adds a node for the post. It adds an edge connecting the post to its author. It adds an edge connecting the post to its containing topic. If there are post replies, then you add an edge to the post from the post being replied to. So you can see how I just imperatively go ahead and like add more nodes to the graph, add more edges to the graph, and then you finally have your completed thing.
Yeah, I understand why you guys moved to Flow now.
Yeah, we've had some pretty good success with using Flow. It's like saved us a bunch of time. When I'm developing SourceCred stuff, I generally just have a Flow server running in the background and perpetually telling me if I make a mistake. So if I like, make some mistake here, I get very fast feedback and I can go and fix it. The other thing to talk about is weights. We kind of just refactored the system so that it's possible to set weights on the level of individual nodes and individual edges. So we don't actually have examples yet of this in the code base, but we will soon. And that's where, for example, if the Discord plugin is minting a variable amount of cred on a reaction based on what channel it was in or who authored the reaction or what kind of reaction it is, that's where we will use our ability to set custom weights on those nodes. Cool. So that's like an overview of the plugin system. I think I'll just show one more thing, which is how this shows up in the SourceCred UI. So when we go to the SourceCred UI and we click Show Weight Configuration, we see all these same node types. So like the discourse declaration said there's a topic, post, and like types, and here we can set the weights. As you can see right now, we're doing all of our minting on likes. So every time there's a like reaction, the node representing that reaction, which is connected to the post getting a heart, mints, in this case, 16 cred, which then continues to flow through the graph. Cool.
That's like what's the parameters that work best for you guys. How you construct some discourse.
Yeah, so the reason that we mint cred on the reactions rather than the posts directly, and there's actually a whole thread on our discourse discussing this change. If you search for like minted cred, you'll find it. The reason we did that is because if we mint cred directly on posts, I could show up and just like make 100 posts that don't actually add to the discussion, but I'll mint a bunch of cred. And so we think we want to move cred more and more towards things that are reviewed. So a like is sort of an informal review of a post. And you can think of like a pull request getting merged as an even stronger review of a pull request. and then completing a quest will be like a review of some unit of work. So I think, for example, like with the questing system, I would imagine moving a lot of cred into completing quests rather than into just raw signals like likes and reactions, because the more reviewed it is, the more appropriate it is to mint cred from it.
So like in this way, like let's say the only thing that mints cred is completing quests. So for cred to flow in discussions, it would be like you have to complete these quests so that you have some cred so that it can flow to things that you react to.
Right.
Without having the actual reaction minting its own cred, but it still flows cred through that reaction just because you completed some quest.
Yeah.
Okay.
Cool. So that's my overview of the plugin system. William, do you think there's any content here that should have gotten covered that wasn't? Cool. All right, I will stop this recording.